Have you ever stopped and wondered what's really going on inside those massive data centers that are powering our new AI world? Well, it turns out the key ingredient is something that started its life with a much, much humbler goal, making video games look absolutely incredible. Okay, let's dive into this amazing story of the unlikely hero of the AI revolution. So, what is the secret ingredient making things like ChatGPT even possible? The answer isn't the computer's main brain, but actually its super-powered sidekick, the graphics processing unit, or as we all know it, the GPU. So in this explainer, we're gonna cover exactly how this all happened. We'll start with AI's secret ingredient, then trace the GPU's wild journey from gaming to AI Grandmaster. We'll also unpack Nvidia's powerful software moat, look at their absolutely relentless upgrade cycle, and finally explore why computing power is fast becoming the new global currency. All right, let's start with the basics. To really get why GPUs are so critical for AI, we first have to understand the traditional brain of the computer and why it just wasn't up to the task on its own. Every computer has a central processing unit, a CPU. For decades, this thing has been the undisputed star of the show. It's a fantastic generalist, absolutely brilliant at tackling a huge variety of complex tasks one by one. We call this method sequential processing. And right here, this is the core difference. A CPU, with its few really powerful cores, is a master of tackling tasks one after another. But training an AI model, that involves trillions of simple calculations that all need to happen at the same time. That's where the GPU, with its thousands of smaller cores, becomes the absolute hero. It's literally built for this kind of parallel processing. I love this analogy. It's perfect. Think of a CPU as a world-class master chef, meticulously creating one incredibly complex gourmet dish. A GPU, on the other hand, is like an entire army of line cooks, all chopping carrots at the exact same time. For the massive, repetitive work that AI needs, you don't want the master chef. You need the army. So how on earth did a chip designed for gaming become the undisputed master of AI? Well, this was not a planned journey at all. It was more like an accidental discovery that ended up changing the world. Let's trace that incredible path. Back in 1999, Nvidia's first GPU changed gaming forever. But the real game changer, the moment that set the stage for everything we see today, was in 2006 with a thing called CUDA. This software platform was the key that unlocked the GPU's parallel processing power for scientists and researchers, not just gamers. You fast forward to 2022, and the launch of ChatGPT creates this just insatiable demand for this power, catapulting Nvidia's data center business to over 90% of its revenue today. It's wild. And this isn't just happening in some far-off giant data center. The power of the GPU is behind the tech you and I use every single day. When Netflix recommends a movie, when you ask Siri for the weather, or when you use an AI chatbot for customer service. Yep, all of it is powered by this parallel processing revolution. Now, you might be thinking, well, can't another company just build a better chip? It's not quite that simple. Nvidia's dominance isn't just about the silicon, it's about the incredibly powerful software ecosystem they built around it. 2 million. Just let that number sink in. That's how many developers have learned to code and build applications specifically for Nvidia's CUDA platform. This isn't just a user base, it is a global army of innovators, all building on one company's foundation. So what exactly is CUDA? Well, think of it as the ultimate software bridge. It basically gave developers the keys to the kingdom, letting them unlock the raw parallel processing power of the GPU for any task they could dream up. For nearly 2 decades, this has created a massive, almost irreplaceable library of AI code, all perfectly fine-tuned to run fastest on Nvidia hardware. And all of this creates a powerful competitive moat. Switching to a competitor isn't as simple as just buying a new chip. No, it means rewriting years of code, which can take a whole team up to a year to do. With thousands of ready-made tools and a community that just keeps growing, it's an ecosystem that competitors find almost impossible to break into. And you can literally see the financial power of that software moat right here on this chart. In 2023, as the AI boom just took off, Nvidia's gross profit margin actually shot past that of its own manufacturer, TSMC. That just shows you that the real value isn't just in making the chips, it's in designing them and controlling the software that makes them completely indispensable. So how does Nvidia protect this incredibly powerful position? Well, they don't just sit back and relax on their software moat.
They innovate at a pace that is, well, it's just breathtaking, keeping competitors constantly playing catch up.
And here's their strategy to stay on top. The company has intentionally shifted to a one-year product cycle. That's a new, more powerful chip architecture every single year. The goal? To make their own products obsolete before anyone else even has a chance. You can see this relentless pace right here. The Hopper chip? It dominated the initial AI training boom. Then came Blackwell, designed for something called inference. That's the actual running of the AI model after it's been trained. And it wasn't just a small improvement. It delivered a massive 10x leap in efficiency. And now, the upcoming Rubin architecture is already promising another 3 to 5 times leap beyond that. It's just an incredible speed of innovation. You know, this story is bigger than just one company or even one industry. This relentless demand for computing power, or compute, is now shaping global politics and creating a totally new kind of power struggle. And this has given rise to a brand new concept: sovereign AI. Nations are waking up and realizing that to compete in the 21st century, they can't just rely on other countries for their AI infrastructure. No, they need to build and control their own to protect their data and secure their economic future. And believe me, this isn't just a theory. Countries all over the world are pouring billions into creating their own national AI clouds. The UK, South Korea, Germany, Japan, France, they're all in a massive race to build their own AI factories. And that means buying hundreds of thousands of these high-end GPUs. And when they go shopping for those GPUs, well, there's really only one place to turn. Just look at this market share. As of late 2025, they control an estimated 92% of the entire AI accelerator chip market. It's less of a market and more like a kingdom. Nvidia's CEO, Jensen Huang, he really captured this shift perfectly. He says we're now in the AI factory era. This isn't about small-scale experiments anymore. This is about the industrial-scale production of intelligence, all powered by these GPU-driven data centers. Which brings us to our final and pretty thought-provoking question. With a new, more powerful generation of chips arriving every single year, we're entering a world where a nation's influence might be measured not by its army or even its economy, but by its raw processing power. What does that future even look like?